This will be for the con exercise, visually assess standard deviation. So just a rough definition of standard deviation. It is basically how spread out the data is. So I'll just show you a few little examples. So just a rough sketch. Let's say this is like a number line, and the left-hand side is the lower numbers, the right-hand side is the higher numbers. This would be low standard deviation right here. And that is because the standard deviation is how spread out the data is. You can see right here, the data points are not very spread out. We don't have many points that are excessively high or excessively low. So since these are not spread out, this is a low standard deviation. Okay, and if you take the points and you spread them out a little more from left to right, the standard deviation will be a little bit higher. Okay, so it increased from the first example. And then if you take the points and spread them out even more, notice there's more points on the extreme low end and the extreme high end. Now the standard deviation is even higher than the other two examples, because again, the data points are more spread out from left to right. So the more spread out it is, the higher the standard deviation will be. Okay, each dot plot below represents a different set of data. Order the data sets from largest standard deviation on top to the smallest standard deviation on the bottom. Okay, so the ones that are more spread out will have the largest standard deviation. That one goes on top. All right, so we only have 3 data sets. And which one is the most spread out? Well, clearly we can see this one right here. Okay, because the dots are on the extreme low end and high end. You see that? So this one is more spread out. This one, the dots are closer to the center. All right, so you just left click on it and drag it, but this one is already in the right place. They said the largest standard deviation goes on top. So the one that's the most spread out goes on top. And the one that is the least spread out goes on the bottom. So you can see this middle one here. The dots are more in the middle. Okay, so they're not as spread out as this one right here. So I'm going to left click, hold it, and drag that to the bottom. All right. So if you were to draw a curve on each one of these, the curve on this one would be like that. See how it's more spread out because there's more data on the left and the right. It's basically more spread out. This one here is kind of evenly distributed. All right, and this one here, it's more distributed. It's more distributed in the middle. Okay, so this one is the least spread out, and this one is the most spread out. So that's why this is on top and this is on the bottom. All right, so I think all of these problems are the same. The largest standard deviation is on top. The smallest one will be on the bottom. All right, let's see. So the one that's the most spread out will be on the top. Okay, we can see here, we all have, all of these have 8 dots or points. We can see the one on the bottom has the dots on the higher and lower end than the one here. See, this one here has more dots in the middle. And same with this one here. So I can see the one on the bottom is the most spread out. So I'm going to drag that and put it on the top. All right, you just left click, hold it down, and drag it up to the top and then let go. Okay, and out of the next 2, I can see that this one is more spread out than this one. Okay, so this one is the least spread out. That's why it goes on the bottom. This is the most spread out, and this one is medium.